This video will show how to run external scripts through the command line in VisualAnalysis. Let's get started. In addition to using the command line directly, as shown in previous videos, more complex scripts can be generated in any text file and read into the program. This allows models with complex geometry to be created, parametric studies to be performed, finite element meshes to be automatically refined, and much more. Note, when developing external scripts to be ran in VisualAnalysis, any valid C# code can be used, along with the commands that are already built into the program. The help file contains a number of example scripts, so let's launch the help file and navigate to the external scripts page. We will start out by looking at the simple frame example. This script builds, supports, and loads a steel frame. Let's copy the code to the clipboard, paste it into a text file, and save the file. Now we can type browse into the command line in VisualAnalysis and navigate to the file we created and open it. We see that VisualAnalysis generates the nodes and members, sets the support conditions, and applies the loads almost instantaneously. One advantage of using a script is that you can easily change the parameters in the script, save it, and read the script back into the program. Note, in addition to typing browse into the command line and navigating to the file each time, we can simply enter the path into the command line. Next, let's look at the Catenary arch example script. This script builds an arch with an inverted catenary shape and demonstrates how scripts can be used to generate a model with complex geometry. While we could save this example in a new text file, for convenience, we will just replace the code in the external script text file. Loading the script into the program, we see the catenary arch that the program generates. Note, this arch was specifically programmed to have equal member lengths along the arch. Now let's look at the refine mesh example script. This script builds and loads a shear wall and refines the mesh of the wall until the displacement of the wall converges. Note, inside the while loop in this script, the await analysis command is used to pause the script until the analysis completes so that the displacement of the wall can be obtained to compare with the displacement from the previous iteration. Saving this example in a text file and loading it into the program, we see that the shear wall is generated, the support conditions are set, and the load is applied. Next, we see that the mesh of the wall gets successively finer as the script iterates towards the converged solution. Finally, we see that the displacement of the wall converged. The difference between the displacement in the previous iteration is about 500 thousandths of an inch, and the final displacement is 0.2 inches. We also see that it took 11 tries before the model converged. Finally, we'll look at the moving load example script. This script builds a custom moving load on an elevated concrete slab and assumes that the moving load is from equipment that is driven halfway across the slab, turns 90 degrees, and drives off the slab. Saving this example in the text file and loading it into the program, we see the concrete slab that was created with the hole in the slab, along with the nodes that were created for the moving load. Scrolling through the service cases with the keyboard, we can see the load move across our structure. In just a few minutes, we have used the command line to run external scripts to build a simple frame, generate a catenary arch, refine a mesh to convergence, and generate a custom moving load on a slab. These examples just scratch the surface of what can be done with external scripts in VisualAnalysis. We hope you find this new powerful feature useful and it increases your productivity in the program. Thanks for watching and have a great day.